Hey everyone. So you've made a theory. You've thought carefully about spuriousness, about the possibility of reverse causation. You've thought about all the various other variables that could have some kind of effect on our outcome and that might be also related to our independent variable, meaning that we need to think about these, keep them in the back of our heads as things to include, maybe in an analytical study down the road when we get into the data. But now we've distilled this theory and we want to try to codify our expectations into a concrete and testable form. We want to get again, from that very complex theoretical environment, we're writing about all these different influences, all these different properties of the link, the causal relationship between our independent variable concept and our dependent variable concept. We need to boil this down into a single statement. And so from all that complexity, we're going to derive a very simple thing called a hypothesis, which devises our expectations that we will soon be testing. So the anatomy of a hypothesis is quite straightforward. First, we have a single independent variable. Now you'll notice, importantly, that this is not an independent variable concept. This is now an independent variable. So now we're boiling our study down into a statement which contends with a measurable outcome. So something that we are going to want to think about in the process to come of operationalization. So we want to think about a measurable variable, something that has a scale that we can measure that's going to increase or decrease in some kind of linear way. We also have a single dependent variable. We've got some kind of variable that is the stand-in for our dependent variable concept. We have a theoretical direction, that is whether or not we expect this relationship to be positive or negative. And then we have the unit of analysis, which is going to correspond again to the statement of this population that we've put into our research question. So it looks very much like our research question, but it's got a couple of additional components that we need to think carefully about. First is the fact that we've got mentions of specifically quantifiable variables here. And then, of course, importantly here is the specification of a theoretical direction, which tells us whether something is going up or down based on its positive or negative association. Now, I should also mention that as we're reading the textbook, you'll see a discussion of what's called a null hypothesis and a main hypothesis. So the null hypothesis is, by the way, this is something that students really struggle with. And I'm going to try as much as possible to make clear why we specify a null hypothesis and what it's for, and why we specify a main hypothesis. So this goes back to statistical logic. So in statistics, oftentimes when we're testing a hypothesis, when we're testing a statistical relationship, we are operating against a default state of skepticism. Essentially, we're saying, let's assume a world in which there is no relationship at all. Okay, Ellie, the cat, really wants you to know about this. Let's assume, says Ellie, a relationship where simply there's just no association, no correlation whatsoever. And so the statement of the null hypothesis is to say there's nothing there. There's no relationship. So that is our default state of skepticism. It's H0. It's to say this is the world in which our, going back to our earlier example, socioeconomic status has absolutely no effect on whether or not people call themselves progressives. So rich people call themselves progressives, poor people call themselves progressives, middle income people call themselves progressives, and the rate of whether or not you call yourself a progressive does not change substantially whether you're rich, poor, or in between. Okay, it's the default state. Why we do this, it traces back to this statistical language, but again, we can also state, in addition to this null hypothesis, the opposite, which is to say, let's compare this case of the null, the world where nothing is related, to a possible alternative, right? That is what we call the main hypothesis, and that is the one where we say, but what if? Right? We've specified a world in which there's no relationship, but what if there was? What if there was a relationship? We need to have some kind of direction in that hypothesis that codifies our expectations. So for examples, we could say, in a comparison of American millennials, so here's my unit of analysis, I'm comparing American millennials, I hypothesize that higher values of self-reported liberalism, okay, so whether or not you call yourself a liberal, are associated with greater support for Bernie Sanders, all else equal. So if I want to know which American millennials like Bernie Sanders, I might speculate it's the ones who call themselves liberals, the more liberal supporters are going to be Bernie Sanders supporters, and the people who don't call themselves liberals are not going to like Bernie Sanders as much. And so you can see here that there is a direction built in here. Higher values of liberalism are associated with greater support for Bernie Sanders. So we've got, in this statement, we've got higher and greater, which indicate a positive association. When one goes up, the other one also goes up. It's positive. So I think a really nice way to phrase this almost always is to keep this first piece always going higher. Okay, so let's imagine you're going higher on the liberalism scale. Then you can see what might happen to your outcome. Either it becomes greater or it becomes lesser. So again, the null hypothesis is, again, one in which we observe a world where there's no change. In a comparison of American millennials, I hypothesize that higher values of liberalism are associated with no change in support for Bernie Sanders, all else equal. And all else equal is quite important because this is a phrase that's capturing a recognition. We're not going to be talking about any of this other stuff in the hypothesis, just like in the RQ, it's just one simple statement. The all else equal is acknowledging there's a lot of other stuff going on here. There might be intervening variables, there might be other kinds of things that actually do influence this relationship. We're going to leave that aside for the moment until we get into the specification of our actual statistical models. But for now, we're going to leave all else equal here at the end of each hypothesis, both our main hypothesis and the null, in order to at least acknowledge the fact that this is a more complicated world than the one that we've suggested in this hypothesis. So some more examples. Well, we're going to see some more examples in class, but again, I want you to think very carefully about this idea that we've got a direction here. And we could think about an alternative hypothesis, right? H2. In a comparison of American millennials, I hypothesize that higher values of self-reported liberalism are associated with lesser support for Bernie Sanders, all else equal. We might wonder, why would liberals not like Bernie Sanders? I don't know. That's something for your theory to explain. So again, stay tuned for more examples when we meet in this week's class. Until then, I wish you the best of luck in your preparations, and make sure to read the textbook for more information about the statement of hypothesis. I'll see you then.